for being patient and hanging in there, and I wish I could offer you all tea and scones to keep you going through the talk. Okay, so I just wanted to acknowledge Nicole's contribution to the work and to the talk, and also Hugh as well was instrumental in getting this work underway. And so what I wanted to do is to talk about developing a post-fire restoration framework for shrublands, and specifically within that, the development of a tool, which we are calling the PREP tool, the post-fire restoration and prioritization tool, and also to demonstrate how the outputs of this tool can be integrated with other data sets to try to refine where to conserve or restore on the landscape, and also to try to inform species for use in restoration. So as we've seen over the last day and a half, the characteristics of shrublands that had once allowed it to be known as a resilient community type of wildfire recovery, maturity and old growth, these have been disrupted by various things, disturbances, such as the too frequent fire, drought, non-native species, as well as other things like nitrogen deposition. So the aim of the tool was to bring together a lot of these threats to shrublands. And what I wanted to recognise, as we've seen before, the areas that have had sort of the fire return interval within that 30 to 90 year window, the way it recovers, the natural shrubland regeneration, compared to areas of low regeneration capacity where non-native species are taking over. And the ramifications of that is that these are now prone to erosion, they have low carbon storage, lower plant diversity, and provide flashy fuels. So how then in these landscapes of low regeneration capacity, how can we identify where the restoration opportunities are, especially when some of these areas are so vast? So the origins of the tool we developed started off in Spain, and I wanted to recognise our collaborators over at the Mediterranean Centre for Environmental Studies. So they had developed a technical framework for applying to forest fires in Spain that integrated many of the factors that we now adapted for the Southern California tool. So we took their framework and then we included extra components to it, like including things like non-native species, and also built the user interface for it for resource managers to use here. So the PREP tool then is a conceptually straightforward tool, and it uses a pixel-based scoring system to assess regeneration capacity on the landscape. And it's currently built in a Jupyter Notebook framework, and there are options in there where a user can change certain thresholds or decisions and include different types of data sets if they want to. So where we applied it to test it was on the copper fire, shown in red, and we also did some validation in the powerhouse fire in the orange. So it consists of 5 steps. The first step is to generate species information on the landscape. So what we did, in comparison to the Spanish tool that had very detailed species information maps, we didn't have that data available when we developed it. So we used proxy units, these landscape units, and we developed these using vegetation type and also aspect and topography. So, for example, we've got mixed chaparral, south-facing slopes, summits and ridges, and then we've got chemise chaparral, north-facing slopes, valleys and depressions. And then once we had these units, we wanted to characterize them by the proportion of obligate seeding species or dominant resprouting species. So this really drives the sort of the baseline for the tool, is the percent cover of areas, those units which can resprout, or so either resprouting species or facultative seeding species that have the ability to resprout. And again, if a user has more detailed information of a particular area, then those cover classes can be modified as needed. And so points are awarded to those landscape units based on those characteristics of whether they're resprouting or cedar-dominated areas. And this is our sort of our base map from which we deduct points. So areas in green have high regeneration capacity, and down to the red areas with low regeneration capacity starting out, just based on the proportion of resprouting and seeding species. So step 2 of the tool integrates data on fire history. There's 2 components to this. First is looking at the number of fires in the last 40 years. And the critical thing here is identifying areas on the landscape with 3 or more than 3 fires. So those pixels that have those characteristics of 3 or more fires in the last 40 years, points are deducted from those pixels. And that attribute, the number of fires in the last 40 years, is now in the FRID data set, so it's readily available for using for current and future fires. And so points are deducted for both pixels which are characterized by high numbers of resprouting species or high numbers of seeding species. The other fire history component is time since last fire, and here we're interested in areas on the landscape that have 0 to 5 or 5 to 10 years since the last fire, because a lot of the information we've heard already in the symposium about the effect of this on seeding species. So the scoring system here, where points are deducted, affects primarily those pixels that are dominated by obligate seeding species. And so we can see the previous output of the tool is in the upper left here, and here we can see the modification that has been made based on deducting points because of the fire history. So those circles in blue we can see have changed colour between the 2 maps. The third step of the tool looks at drought conditions, and in the tool it takes you to a NOAA site, so you can query the Palmer Drought Severity Index for the ecoregion that the fire is that you're working in. And we're interested in the number of months in the growing season between November and May that are categorised as severe or moderate drought. So we look at the growing season before the fire. Points are deducted for pixels that are dominated by resprouting pixels because of the drought affecting the stores of carbohydrates. But we also look at the growing season post-fire in years 1 and 2. And this affects both types of dominated pixels, the resprouters as well as the obligate seeders. But it's more detrimental to the obligate seeding species because of the impacts on germination and survival. The fourth step looks at the percent of non-native grasses, and this is an area where the user can specify the threshold. For this map of the copper fire, we're using a threshold of 20%. Above this threshold, we think that it means it causes a detrimental impact to the regeneration of the shrublands, but the user can change that. And the user can also input a different data layer for the non-native grasses. So this is using Isaac Park's data on annual herbaceous species across Southern California, but there's more recent data sets that could be integrated here. And the scoring system for the non-native grasses affects primarily the obligate seeding pixels. And so we can see here the change between the upper left and the main map. This area here in orange has been downgraded from the moderate to the moderate low category because of the presence of non-native species there. And so this is the output of the first 4 steps, is the overall regeneration capacity for the copper fire. And we can see that over 20% is in high regeneration capacity, but 9% is in the low regeneration capacity site, so providing a sort of a small area within which investigations could be made into specific areas for restoration. Now there is a final step of the tool, and that is one that has been used more heavily in the Spanish framework, and that is to look at the risk of soil erosion. And we did include this, but we didn't for the copper fire because it happened so long ago. So the risk of soil erosion can be included, and this is an output that is generated from the burned area emergency reports, assessments that are done post-fire, and we've integrated the regeneration capacity and the soil erosion to provide a degradation risk map. And we did some validation of the outputs using plots on the powerhouse fire, and our assumption would be that areas of low regeneration have higher abundance of non-native grasses and herbs and lower abundance of native shrubs. And that's what we found. If we look at these graphs, we can see for the grass cover proportionally more in the low regeneration classes, and the shrub cover is proportionally less. I also wanted to touch on how we can use the outputs from the PREP tool with other information to try to hone in on specific areas for restoration. So these are using data from the EcoServe tool, the 4 ecosystem services here, runoff, recharge and biodiversity and biomass. So we can integrate those together to provide hotspots of services. In the map on the left there, you can see the red areas have got the highest number of those 4 services overlapping. And what we can do then is to overlay the regeneration capacity of the tool with that hotspots data. And candidate areas for investigating more for restoration would be where they overlap. The red areas and the black outlines would be good areas to investigate. Another thing is to integrate the outputs from the tool with roads and trail data to identify restoration sites. So we ran the tool for the Pyru fire to just see which areas would be recommended, but when we overlaid the roads and trails, it did pick up on the area that Shane had decided on originally. But it was good to know there were other options available, and you know, it was a useful practice to use the tool for that. And so, as we've seen in the previous few talks, this area that was highlighted in red in the output map is certainly sort of annual grasslands and degraded compared to other areas on the other side of the road where there's more shrubland. And then the final example of how it can be used, the outputs from the tool, is it can be integrated with future climate data. So these data here in the map are from Jim Thorne at UC Davis. So what he did was to look at a couple of different climate scenarios, the MIROC, the hot-dry, and the CNRM, the hot-wet scenario, to see where they overlapped. And here we're looking at the southern part of that copper fire. And areas in that sort of leafy green colour are climate refugia areas where the climate's going to be stable. And in these areas that the pre-fire species composition is likely appropriate. And this can be contrasted with the high climatic exposure areas shown in the red, where drought-tolerant species might be more appropriate. And so just a little bit more information on those drought-tolerant species, as we've seen in Brandon's talk, and also Shane and Carla's talk. Here we're looking at percent survivorship rather than percent mortality, but the same characters are coming up again and again, the Artemisia and Celia and Eriogonum, compared to some of the more chaparral species. So then, just to conclude then, that the PREP tool can provide a rapid assessment of the recovery potential for shrublands, particularly these vast landscapes which aren't possible to visit on the ground all the time. Also, the way it's set up is that users are able to modify the decision rules and also some of the input data into the tool. And then some of the examples we showed were how the outputs can be integrated with road data, trail data, or climate data to really try to refine where to work on the ground. And with that, I'd just like to finish with acknowledging the funding sources for the work and also the people we worked and helped to create it.